In this video, we are going to learn how to find areas of sectors and areas of an annulus. So let's go ahead and take a look. A sector. Well, a sector is like a pizza slice of a circle. So it's a region bounded by two radii. So here would be radii 1, there's radii 2, and the arc lying between the radii. So this part right here. So we're talking about this area. Well, the area of a sector is just a fraction of the area of the circle. So this area is proportional to the central angle. In other words, the bigger the central angle, so the bigger this angle is right here, the bigger the area. So here's our formula. Since we're talking about area of a circle, we're going to go ahead and take pi r squared. And if I'm talking about just that sector, I'm going to go ahead times theta, which is my central angle, divided by 360 degrees. A circle is a total of 360 degrees, so I don't want all 360 degrees, I just want a specific angle. So that is how we find the formula, or that is how we find the area of a sector. So let's take a look at an example. We want to find the area of the sector. So I'm going to go ahead and write my formula, which is pi r squared times my theta value, divided by 360. Well, I'm going to plug in my variables. I have pi. The radius is 2 centimeters, so 2 squared times. My theta value is the angle, and so the angle I'm talking about is 60 degrees, so 60 divided by 360. Well, let's simplify this. 2 squared is 4, so I have 4 pi times, and if I do 60 divided by 360, well, I know 60 goes into 360. How many times? Good, 6 times. So it's going to be 1 over 6. Well, I'm going to multiply straight across, so I have 4 pi on the top. If I make 4 pi a fraction, it becomes 4 pi over 1, and 1 times 6 is 6, and I can reduce that to 2/3 pi. We're going to go ahead and leave our answer in terms of pi. That's more exact. So the area of that sector is 2/3 pi, don't forget units, centimeters squared. Let's take a look at another example. I want you to find the area of the shaded region. So I'm going to go ahead, have you pause the video, and when you think you're done, come back and we'll see how you did. Welcome back. So if I want to find the area of the shaded region, well, since it's a square, since it's 24 by 24, I know these are all right angles. So all of these sectors consist of right angles, and I have 4 of them. So really, if I were to take a circle and divide it into fourths, that's what each one of these sectors represent. So I actually have a full circle. So to find the area of the shaded, I'm going to find the area of the square. So I'm going to take 24 times 24, and I'm going to subtract out the circle. So let's go through that. Well, I'm going to go ahead and take 24 times 24, and I end up with 576. And I'm going to subtract pi r squared. So what we have to figure out is the radius. Well, right here is a radius. Right here is a radius. So it looks like there are 2 radii that make up 24, and the radii are going to be congruent. Therefore, my radius is 12. So I'm going to go ahead and take 576 minus pi times 12 squared. Well, that's going to be 576 minus 12 squared. It's 144 pi. Now I can't combine like terms here because that pi is kind of like a variable. So I have 576 minus 144 pi feet squared. Or I could go ahead and plug this into my calculator and take 576 minus 144 times pi. And I get about, and so that's what that little squiggle equal sign means, approximately 123.84 feet squared. So that's how we can find area of sectors. Now we're going to talk about an annulus. And so an annulus is part of a large circle remaining. Well, it's the part of the large circle remaining when the small circle at the same center is cut out. So the annulus is the shaded green area. And for us to find the area of the annulus, we go ahead and we take the area of the large circle and we subtract out the area of the small circle. So an annulus is kind of like a dartboard. We can think of it that way. Let's go ahead and take a look at an example. I want to find the area of the following annulus, and it says using 3.14. We're going to do it both ways. We're going to leave our answer in terms of pi, and then we'll simplify it out with 3.14. So our formula said area of the large minus the area of the small circle. So if we look at the large circle, that would be the outside one, and the radius there is 12. So pi r squared is going to be pi times 12 squared minus. Now I'm going to subtract out this smaller inner circle, and the radius of that is 7. So I'm still going to do pi r squared, but minus pi times 7 squared. So let's simplify this. We know 12 squared is 144. So I have 144 pi minus 7 squared is 49, and don't forget your pi. So now I have 144 minus 49. Well, that's going to give me 95, and I have to carry that pi with it. So the area of the annulus, or the area of the shaded, is going to go ahead and be 95 pi meters squared. Now if I want to use the 3.14 as the directions say, I'm going to use my little squiggle because it's approximately that. And take 95 times 3.14. And we end up with 298.3 meters squared. So there is also a way to express the area of the annulus. So there you go. We just reviewed how to find area of sectors and area of an annulus. Great job.